Hello, today we're going to do section 9.2, summation notation. First of all, let's actually define what this notation is. We're going to use the capital letter sigma. Then you have your indexing variable, and where it starts, it usually starts at 0 or 1, and then it goes to the ending value on top. Then you tell it what you are adding, which will be a sub I. So this is the notation. And what it means is a sub 0 plus a sub 1 plus a sub 2 plus ... plus a sub n. So it's just a short way to write when you're adding unlike things together, but a lot of them. So example 1 is to actually find these sums. So for a, we'd have 13 over 100 to the first power, plus 13 over 100 squared, plus 13 over 100 cubed, plus 13 over 100 to the fourth. Oh, I gotta be careful there. There we go. And then you would add these together and you get that answer. Now for B, you do need to know what n factorial means. I'll do that off to the side over here. N factorial means to take n times n minus 1 times n minus 2 times, and you keep decreasing the number until you get to 1. So for example, 6 factorial is equal to 6 times 5 times 3, times 4 times 3 times 2 times 1. And you would multiply that together. So for B, we have 0 factorial over 2 plus 1 factorial over 2 plus 2 factorial over 2 plus 3 factorial over 2 and plus 4 factorial over 2. Another thing I forgot to mention is that 0 factorial is defined to be 1. So we get 1 over 2 plus 1 over 2 plus 2 over 2 plus 6 over 2 plus 24 over 2. And you add that all together and you get 17. C, this will be negative 1 squared over 1 times x minus 1 to the 1 plus negative 1 cubed over 2 times x minus 1 squared plus negative 1 to the fourth over 3 times x minus 1 cubed plus negative 1 to the fifth over 4 times x minus 1 to the fourth plus negative 1 to the sixth over 5 times x minus 1 to the fifth. Now you simplify this, get x minus 1 plus, negative 1 cubed is negative, so minus 1 half x minus 1 squared plus 1/3 x minus 1 cubed minus 1/4 x minus 1 to the fourth plus 1/5 x minus 1 to the fifth. I did forget to mention that the indexing variable is n, so that's why I only replaced the n's with 1 through 5. The x is not an indexing variable, so the x got left alone, and that's why our answer has x in it. Now for example 2, we want to rewrite the sum using summation notation. To get practice for this, you are going to have to do the highlighted problems in this section. So for this one, I'm hoping you notice that this sequence is arithmetic. So I'm going to come up with a general expression for this, a sub n, which is a sub 1 plus n minus 1 times d. And d is 2. If you simplify that, you get negative 1 plus 2n. Well, that is what we're adding. So our summation notation is going to be the sum from n equals 1 of negative 1 plus 2n. And we'll usually put parentheses around it in these types of scenarios. But where do we end at? Well, we end when negative 1 plus 2n equals 117. So I go ahead and solve this. And we get n equal 59. So we end at 59. So it's the sum from 1 to 59 of negative 1 plus 2n. Now for B, this is very similar to problems that we did before of where you want to rewrite it as a fraction. And this is how I'm going to rewrite it. And you notice that the top is geometric because you multiply by negative 1 each time. So the top will be a1, which is 1, times negative 1 to the n minus 1. And the bottom is arithmetic, where you're adding 1 each time. So the bottom will be a1 plus n minus 1 times 1. And that comes out to be just n. So what we're doing is we're taking the sum from n equals 1 to something of negative 1 to the n minus 1 over n. Well, and since n is equal to the denominator and we stopped at a fraction with a denominator of 116, this one goes until 116. Now for C, there is a typo here. That shouldn't say n minus 1. Let's put 31. So I'm hoping you recognize this as the geometric sequence that we did in section 9.1, in which case a sub n was equal to 0.9 times 1/10 to the n minus 1. So then we're taking the sum from n equals 1 of 0.9 times 1/10 to the n minus 1. So for this one, to solve it, because there's 31 zeros here, and I want to figure out when is it equal to 0.9 times 1/10 to the n minus 1. I'm going to rewrite it in scientific notation. Well, this is the same thing as n times 10 to the negative 32, because you would have to move the decimal place 31 to get it here, one more to get it there. So that's why it's to the negative 32. And this is equal to 0.9. Well, 1 over 10 is the same thing as 10 to the negative 1. Then, what do I want to do? Divide by 9. Divide by 9. We get 10 to the negative 32 equals 0.1 times 10 to the negative n plus 1. Because 0.9 divided by 9 is 0.1. That's where that's coming from. Multiply both sides by 10 to get rid of the 0.1. That's 10 to the negative 31 equals 10 to the negative m plus 1. So negative 31 equals negative m plus 1. And I'm running out of room. I'm sure everyone can solve that, so n will equal 32. So in summation notation, this is the sum from n equals 1 to 32 of 0.9 times 1/10 to the n minus 1 power. And that'll be it for this part of section 9.2.